Good afternoon. I have great pleasure in introducing today's IMechE webinar, and even greater pleasure presenting Roger Middleton, who is an engineer who has had a prodigious career in the water industry. He's also been for 18 years an active member of the Energy, Environment and Sustainability Group at the IMechE. So there's very little he doesn't know. There's a challenge for you, Roger. COP26, where we were very active last year, saw the outline of some very, very interesting targets and commitments by the governments of the world. COP27 really means that we have to look at the engineering that needs to be behind that to make it happen. And that's what this webinar will address. So with no more ado, I will hand over to Roger.
Thank you for the introduction, and welcome to this Energy, Environment and Sustainability Group webinar. The title is rather grand, Engineering Tasks for Conference of Parties 27 and beyond, but really it's a short outline of what may well be a long haul. So to introduce, climate change, abbreviated here as CC, seems to be someone else's problem, but now, from recent events in July, it's been burning London's doorstep. Most of the COP meetings seemed like political chaos, so now guess who? Engineers need to get us out of the mess. At a recent meeting in Bonn, Africa, least developed nations and small island states said that they've had climate-related loss and damage for 30 years, and enough is enough. So, to clarify, which isn't always obvious on the COP meeting agendas, mitigation is action to avoid the worst happening. In other words, we take that in advance, and adaptation is the way we have to change how we live with the consequences of failing to mitigate sufficiently. And just a note that current thinking among more enlightened people is that if we fail to mitigate substantially, then we won't be able to adapt fast enough to survive. So this webinar will build on an earlier one by Dr. Tim Fox on the COP26 outcomes, and we'll look at tasks for the engineering profession to fulfil commitments that might hopefully be made at COP27 in Egypt, which will be in November this year. But the programs we need to start on to satisfy our commitments to get to what is called net zero will be long term. They'll be 30 years plus. In the meantime, there's an advisory role that engineers can play in formulating, costing and promoting feasible commitments and actions in most industries. So we need to be involved there. We also need to ensure as engineers that our perhaps new normal ways of working are not making things worse. So some reflection on this may be worthwhile. This might include new materials and new methods which present us with challenges, but surely that's what engineers thrive on. So where do we start? The objectives are fairly obvious. We need to get to net zero. And here in the UK, we claim to be leaders in that respect. But there is currently no UK project plan for achieving net zero. So we need to develop one. To get off fossil fuels, we need to do three main things. We need to build renewable energy capacity at big scale for electricity, for transport, fuel, and for heat. We then need to transition to a new mode of resource economy. So either renewable resources or circular economies or both. We need then to double the education effort, not just to train engineers, but to make all engineering better than net zero in outcome, and to take the public and politicians with us. Seems like we're on our own on this task, but in fact we're not. In July this year, the High Court ruled that Her Majesty's government's net zero strategy is actually in breach of law because it doesn't explain how targets will be met. So they have ruled that a ministerial report should be submitted by April 2023. This is great news because I've been reading since 2003 aspirational reports and policies from government that have no basis in reality. So at least the High Court is on our side. Looking ahead to COP27, the agenda has already been compiled and it will have 4 main sections: mitigation, adaptation, finance and collaboration. So this webinar will follow that suit. Note that the UK's presidency continues until COP27 actually starts in Sharm el-Sheikh in Egypt in November this year. What were COP26 outcomes? Well, I won't list them here. Tim Fox has covered most of them. The only other one I would stress is that all the delegates to COP26 had updates and latest information on all the risks and outcomes that their countries face. So no excuses, guys. You can't say you weren't told. Meanwhile, interim meetings in Bonn in Germany and Petersburg, which are more informal and dialogue in nature, have actually made little progress. And with current economic situation and the war in Ukraine, that obviously didn't help. But we have to keep our eyes on the long term. It's also the case that climate change pledges often take second place to domestic issues when delegates get home. Short-termism, I'm afraid, in politics rules. And then, of course, as a major donor country, some foreign aid is cut by wealthy nations. No names there, but we really can't afford to do that. So let's start with mitigation, and we'll focus on energy in the UK. The UK's 10-point plan promises 40 gigawatts of offshore wind, 5 gigawatts of low-carbon hydrogen, plus expansion of new nuclear, all by 2030. But is this enough? Current UK electricity is roughly 43% renewable. And that's about 16 gigawatts at any particular time. So we obviously have to expand that by about 2.5 times to make 100% of electricity renewable. And that will get us to about 40 gigawatts. So the plan was about right at first look. However, as was stressed recently by Scottish and Southern Energy's chief executive, it currently takes 10 to 12 years to get from planning to completion for an offshore wind farm. So 8 years for 40 gigawatts sounds very tight indeed. And basically what we need to do there is treat it a bit like getting a new car to market. That used to take 5 to 10 years. It now takes months. So we need to check that out. But what is our actual demand and where is it coming from? And for this, I'm grateful to Dr. Grant Wilson, another member of the Energy, Environment and Sustainability Group, because he's produced a chart on the next slide. And it shows that electricity demand is between 700 and 1,000 gigawatt hours per day, which is roughly 29 to 42 gigawatts. So obviously the government plan looks like it's in the right area for that demand. Here's Grant Wilson's slide, and there's a lot of information on here. I would encourage anybody with the slightest interest in energy to go onto Grant's site. The chart is interactive. There's lots of things you can do to analyse in depth or in more bigger scale on what's actually happening here. So please sign in, have a look and explore what's on offer. There's a lot of information here. But basically looking just at this frame, along the bottom of the time scale, the chart, around the 1,000 gigawatts per day number on the left-hand axis, we have what looks at first sight like a broad red line. Actually, it's a very fine, jagged line because that's hour-to-hour reporting of UK electricity demand. Above that, there is a sort of square, blocky-looking line in what might be black, but looks actually like a bit dark grey. That's all our transport liquids. So that's petrol, diesel, kerosene, LPG, stuff like that. And that's blocky because it's weekly reporting, not hourly or by the minute. And then above that, there's a very spiky blue line, and that's our total gas demand. Okay, and that is spiky because, again, that's on a much more frequent reporting basis, and it's also obviously got lots of storage in there because we've got some big cycles in there involving a lot of energy. So let's do some analysis on the second line, transport fuels. So we have to do a simplistic analysis just to keep this webinar within time scales. So what we will look at is in the diurnal, seasonal and annual variations. You can actually see the beast from the east in early 2018, and you can see the effects of COVID lockdowns in early 2020. So let's get on with the analysis. The second line is liquid fuels, and we obviously need to electrify these to cater for the expanding electric car market, what's expected to be an expanding van market, perhaps less on HGVs, we're not really sure about that yet, and expanding the electrification of railways and or powering diesels. So demand on that line is from about 1,400 to 1,900 gigawatt hours per day. So that's about 1.5 to twice our total electricity. And remember, to get total electricity from renewables, we needed to multiply by 2.5. So we now have another multiplier of about 2. So that gives us 5 times our current renewable energy to electrify the transport sector. And noting that I haven't included marine or aviation. But that line is quite jagged too, so we also need storage. And storing electricity is difficult. So we may need to convert that, for example, to hydrogen through electrolysis using renewable energy. But currently, that's only about 30% efficient. So that 5 times may become 15 times current renewables capacity. However, the biggest task looking at that chart is obviously to convert our fossil gas-fueled industrial, domestic and transport demand. And we have to electrify that to get off fossil fuels. From the chart you can see that gas demand is from about 1.2 to 5 times our total electricity. So the multipliers there become 2.5 and 5. In other words, about 12.5 times our current renewables capacity. Now, in some applications, synergies might help us. We could take electricity direct from renewables for some industrial and domestic uses. But the main advantage of gas, as we can see from those spikes, is its compressibility for storage. It's a great reserve. So for electricity, we will probably need conversion to hydrogen or something similar, again at about 30% efficiency. So a worst case could be that we actually need about 3 times that 12.5 multiplier, about 37 times our current renewables capacity. And never mind 2030, that looks very difficult by 2050. So to summarise, discounting any significant nuclear power input, and we'll come back to that, we need about 2.5 times current RE for electricity, and that's existing electricity. We need 5 times renewables to eliminate petrol and diesel and get off those fossil fuels. And we need 12.5 times renewable energy to eliminate natural gas and get off those fossil fuels. So that's about 20 times our current renewable energy supply as a minimum by 2050. I'm not sure how far this chart has become available to those who really need it. For example, like the Climate Change Committee. So I'm not sure that these multipliers and numbers are really common knowledge yet, but we really need to broadcast this so we get close to reality. And note there that with the conversions and storage based on current technologies, that task could be closer to about 45 times our current renewable capacity. Now, obviously, from that asterisk, nuclear power has to be seriously questioned, and we'll come back to that. And obviously, I'd be grateful if somebody could check my maths. But please note also that I've ignored carbon capture, use and storage here. And this is because I think as far back as about 2005, there was a UK government competition envisaged to power up 5 carbon capture and storage projects, all different ones to test the technology across the UK. Then we had austerity, and that was taken down to 1 project. And then the government suspected, and I suspect only here, that because I believe in China, it was suspected that they'd already built or were building 3 coal-fired power stations with carbon capture and storage. It was seen that the export opportunities for our technology might have already left us, so the whole thing was scrapped. However, check out the current IMechE project in the northwest of England. That is taking blue hydrogen generated from the Merseyside refinery there, and that is sequestering carbon dioxide from that process to produce hydrogen for a network of pipelines for users in the northwest, and is sequestering that carbon dioxide in the old Liverpool Bay oil field. So that is, to my knowledge, the first carbon capture, use and storage project that we're going ahead with in the UK. I believe that there's another one in train in the northeast of the country, but I'm not up to date with that. So, on these numbers, we obviously need a reality check. And going back to what I consider pretty much the Bible, which is Sir David Mackay's Sustainable Energy Without the Hot Air. And that's an open source book. It's available in PDF form straight off the internet, off his website. And you can interrogate that in any way you wish. It's very flexible, it's online, it's no cost at all, because that's what he intended. But these numbers very roughly tally with his pathway that he went through to explain the process. Looking at the size of that task, he then compared the task of building the UK's offshore wind farms to the enormous production effort of building the US's Liberty ships during the tail end and after the Second World War. And that was more or less taking car building technology, production line stuff, and putting it into shipyards. A huge job. But actually, for our purposes, a more relevant comparison might be the North Sea oil rigs. The stuff that we started developing from the 80s onwards, and all the pipelines and support ships that went into that to make it all work. Now, I haven't done the research on that, and I'm not really up to date with it. But that might provide some sort of reality comparison on costs and timescales to see if it's remotely achievable. But a certain outcome is that we do need a steel industry, so current negotiations are very important, and we need lots of engineering expertise. But having done that reality check, let's question some of the assumptions. It ignores the major changes to all the onshore infrastructure. So that's pipelines, domestic and industrial plant that will have to go alongside our electrification of our current fossil fuels. Now, to some extent, we've done domestic and industrial before when we changed from town gas to North Sea gas. But having in mind for the synergies that we're looking for, to electrify domestic boilers throughout the UK is a big job, much bigger than just changing burners. And the same thing is relevant, obviously, to industry. There are big complications around putting a hydrogen pipework into the domestic domain. It might be suitable for some industrial processes, and that's the basis for IMechE. but replacing all domestic gas piping is another issue. So what we might find is some form of modification to basic hydrogen electrolysis to achieve that. But obviously a good start might be to look at possible energy savings. So this reflects back on a theme of the EESG, which is the energy hierarchy. So save energy before you spend money on it. So things like home insulation, industrial energy efficiencies, district heating systems, so that we use some of that enormous waste from our electrical generating power stations, energy from waste, and synergies across existing physical and corporate boundaries. We really do need to look outside the box for these efficiency gains. For storage and baseload electricity, we will need nuclear generation. Even though I know it's not sustainable, and even though the sources of our fuel for that nuclear generation might be from difficult places. Now, yes, I know this is politically and socially difficult, but a key fact to remember that I don't think many people have got hold of is that the real nuclear waste problem, more than 95% of that is down to our weapons research programs in the 40s, 50s and 60s. Less than 5% of our current nuclear waste problem is down to all the electricity generation that we've done since. So while I admit that nuclear is still a thermal generation process with all those limitations, it is probably very necessary to see us over the gap. Nuclear fusion? This is interesting. When I was a student, that was the bright future. But obviously I was a student a long time ago. And then it was about 30 years away. Until recently, it has still been about 30 years away. But you know what? Based on current power politics, I am very nervous that I cannot trust any particular person or group of people with the ultimate power that at present only resides in the centre of our sun. I think it would be too late, too expensive and far too risky. But that is a personal view, and I don't think that is shared by the IMechE. So just a bit more on mitigation. Methane was identified before COP26 by United Nations Environmental Programme Global Methane Assessment, and that reported in 2021 just before the conference. As Tim Fox said, a lot of the remedial work there within the oil and gas industry is very cost effective because methane is a fuel, so it's a valued resource. So really, for the oil and gas industry, it's a profit improvement exercise. And there are some numbers, even from the USA, to support that it will be very cost effective. We just need to tighten up on some of the technology and our maintenance and future planning and make that future climate proof as well. Agriculture and waste is another matter. Now, just on their own, agricultural and waste methane emissions will take us way over the 2-degree target that was agreed at the Paris conference. So we need to do something about agriculture, and obviously there's stuff like manure, slurries, and even stuff like belching livestock. Research is progressing on that, so they're looking at feeds, additives and all sorts of things to reduce those tendencies, which also will take better care of the livestock themselves. Waste is another issue. In the UK, most of our municipal waste dumps are covered, and the methane that's generated is taken off and used to generate electricity. At one time, that was a major part of our renewables network. That doesn't happen so often overseas, and particularly in developing big nations like China and India, for example, waste dumps are very often open and whole civilizations living on them, picking over them. So they need attention to capture the methane emissions and make use of them and generate electricity for their participants. In the water industry, effluent treatment, wastewater treatment also contributes. So we need some work done on that. Now, before I retired in 2013, that was in progress. There were quite a few ideas being thought about, and by now, hopefully, they've even been tried. Now, methane is already used in the water industry as a fuel from sludge digesters, from primary sludge. So some development on that is also probably necessary. Now, the marine and aviation industries. They both need to transition off crude oil derivatives. Ammonia or something similar seems very likely to be feasible for ships, but just look at them and the size of their machinery. The scale is enormous. However, at COP26, the industry committed to 6 green shipping lanes by 2030. So that would be a really good achievement, so watch that space. Aviation, however, is much more difficult. There is quite a lot of research in academia on this, particularly at Cambridge and Cranfield universities. So things like electric systems, which are 90% efficient, versus current gas turbines, which are only about 30% energy efficient. That seems like a great advance, but kerosene has about 40 times the energy density of an electric battery. So that swamps all the percentage points that we're talking about there. Similarly, synthetics, perhaps distilled or electrolyzed from hydrogen, from water to hydrogen, and biofuels are very doubtful at present, and we'll come on to biofuels later. So aviation has a very difficult problem there, and again it might be about managing demand and restricting access, but that obviously is a very emotive subject. So, normal engineering solutions. How do we go about our day-to-day engineering? Our solutions must be low carbon and sustainable in order to future-proof our industries and avoid making the energy, emissions or waste situations worse. That would probably involve new materials and or materials derived from or the ones that initiate circular economies. So a complete new thought process will be necessary around the circular economy and materials use. Concrete and steel are particularly difficult. Now, steel from one point of view, you can make major carbon footprint gains by using scrap steel and recycling it rather than using virgin iron ore, but there is still a big carbon footprint there. And concrete is even more difficult. So our buildings industry has major problems there. And we need to put rapid development behind low carbon alternatives. There are various engineered timber materials, so we're not going back to Elizabethan barns. Some of them are in use and more are being developed. But obviously, as far as composites and plastics are concerned, we have to be careful there about waste. There is an increasingly visible problem with how we dispose of composites and plastics. We also need to do some slightly different thinking around the problems and solutions that we would currently consider normal. So systems thinking is a way to broaden our outlook and look at the other side of things, conventionally called thinking outside the box. So for example, if we want to convert private cars to electric vehicles, that will certainly help city pollution, but it won't decarbonise our energy generation. Remember, current electricity supply from thermal power stations is only about 20% efficient. The power stations themselves are normally about 35 to 38% efficient, and the rest is lost in the transforming and transmission network. So what comes out of our socket outlets to our equipment is only about 20% of the fuel energy supply that went into the power station. If we then add to that the charger and the battery cycle to charge our electric vehicle, even if that's 80% efficient, it still reduces the overall system to about 16%. And that means that about 84% of our fuel energy, whether it's nuclear, gas or biomass, that goes straight into our atmosphere as heat. And if you add all that up, it is significant alongside the solar input, even to a country like the UK at 52 north. So we are adding significantly to the problem there. And that means that we must convert to renewable supply in step with converting to electric vehicles. Otherwise, we will only make things worse. Now, there are other systems thinking directions that are currently in use and being explored, for example, by the Royal Academy for Engineering. So this is only my personal example. Explore others, they might well affect your industry too. So, let's move on to the second major subject for COP27, which is adaptation. Until recently, we might have thought this was just for other countries and we were safe. But obviously from recent events, that doesn't happen now. Note that the only real certainty with climate change is more extreme weather. Everything else is very educated conjecture. That means that it should be common sense for repairs or modifications to our infrastructure to build back better. Horrible phrase, but I'm afraid I've used it. Now, I am not criticising the power engineers who replaced power lines to remote communities after Storm Arwen in Scotland and the northeast of England. I am certainly not criticising BT engineers who I saw just down the valley from me, up ladders, repairing connections on telephone and fibre optic cables underneath the very trees that brought the cables down just before in a howling gale and horizontal rain. But our developments need to be future-proof. New standards and regulations will probably be needed to make certain of this. And new materials, both low carbon and sustainable, will be needed. And dare I suggest that some major nettles may need grasping and pulling. So, for example, we have gone for a number of decades now with combined drainage systems to our housing and commercial developments. That gives sewage treatment works a major problem because any rainstorm washes out the works and dumps the whole lot in the river. We need to we knew about this problem at least 20 years back. So we need to get to a situation where we separate foul drainage from surface water drainage, because future storms will only make that worse. And don't forget, we are still building significant numbers of homes in floodplains. So Environment Agency advice not to do that must be taken seriously by planning authorities. We cannot develop at all costs, because after their first storm and flooding, any home in a floodplain will not be able to be insured. So let's look at some strategy. Infrastructure projects, we know, get very expensive if they are done piecemeal or on a stop-start basis. Now this came out of the COP26 IMechE two-day conference, so I'm indebted to some of the participants there. And for example, rolling programs are needed for rail electrification. That would have significantly cut the costs of the electrification of the Great Western Main Line. And it could also apply to water industry asset management plans. The 5-year stop-start there as a designer was absolutely ruinous. We'd work flat out for 3 years, and then I might have to go abroad to look for work for the other 2. I think things have improved since I retired, but that really does need much more rolling appreciation by the regulator and government. And I'm sure there are other examples there too. If we look at the possible shifting of freight from road to rail, that would certainly reduce energy requirements and therefore reduce our carbon and renewable energy needs. But even a 4% shift there would swamp the rail network. So again, we need to do a bit of systems thinking around that. But we also need to be aware that the recent hot weather has exposed some defects on the rail network. rail expansion joints don't look to be sufficient, and overhead catenaries have also suffered. I wonder what happened to the old technology that used to compensate for expansion and contraction on signal and point wadding. But I'm not up to date on that, so I may be speaking out of turn. But note, on a technological basis, at least we were warned by the forecasters of that heat wave, so we had a reasonable chance to prepare for it. And that brings us nicely round to nature. In spite of the initial agenda, nature discussions barely made the cut at COP26. Deforestation pledges were the major outcome on that side, but, as I mentioned before, when those delegates take those commitments back home, they may just ignore the signatures. Biofuels, notice, are not carbon neutral. If you need to check that, check some of the machinery that we use for harvesting our forests. And those biofuels don't really work for either aircraft fuel or power generation. Just looking at the business case here, burning a 30-year investment in our forests is a waste of the UK's precious land. We need it desperately for growing food and for growing high-quality construction timber, which we could alleviate the concrete problem with. And as a retired engineer who's been concentrating on the environment for the last 20 years of his career, I would urge you to please tread softly on the earth, because we are only really just finding out how it all works. Finance is the next heading. You might think this has virtually no involvement for engineers, but COP27 hopes to put some numbers onto the loss and damage issues and the adaptation upgrades that particularly developing nations require, but it's difficult to identify and cost these because they're all different. There is a shortage of engineers in those areas to enable them to do that, to work out feasible plans and cost them. It's also very hard to cost aspirations with no real engineering substance behind them in developed countries. So we need to check those aspirations, review them, put some real numbers to them, and that includes all mitigation and adaptation proposals. So there's a huge amount of work for engineers here in all disciplines. Now, as we've seen in the COVID crisis, particularly in the UK and Europe, money doesn't seem to be a problem, or at least it wasn't when the interest rate was low. It's normally people, expertise, and continuity that achieve consistent results. And if we want to go on improving in these areas, we need consistency. It's no good establishing task forces in whatever industry or ministry we decide, and then cutting them and disbanding them 5 years later and hoping you'll build them back up when you need them. That doesn't work. We need continuity to develop expertise. And training such as the IMechE do and adapting will be absolutely key to success here. Now, there is an area in the northeast of the UK that is very conscious of the phasing down of North Sea oil. But actually, a lot of the skills that you need for that market are pretty immediately transferable to renewable energy. So hopefully, with a bit of on-the-job training and a little bit of adaptation, that we should be able to transition those jobs and careers fairly seamlessly. Another aspect of finances is resources and limits. Now, traditional economists say that we don't need limits to resources because immediately we run out of one thing, we can substitute something else. And they don't acknowledge limits to resources. Now, this debate has been going on since Amory Lovins put his oar into the system in the 1960s. And if you really talk to enlightened, particularly academic economists, they will acknowledge that there are issues here. And economics is not a precise science like, say, physics or most parts of engineering. And you also have to ask that if economics is such a precise science, then why have most recent wars been about resources? So, there are also lots of side effects to winning materials, as it's known in the civil engineering industry. So you win materials from quarries, mines, etc. But as developed countries, we usually just pay and we ignore the side effects. And that looks set to continue into things like the battery system and the markets for new materials in new battery systems. They're a good example. They're currently, again, only 1% of the market at the moment, but they involve currently 80% of the resource. So these are elements like lithium, cobalt and nickel. So obviously we need to develop circular economies there. And I believe this sort of thing is going on at places like Warwick University, and there's a pretty open source that declares that it's going on in people like VW and Porsche. So these things are happening, but we really need to accelerate that before we impose unacceptable side effects on remote economies and environments in places like South America and Asia. That brings us on to the fourth item on the COP27 agenda, which is collaboration. And really we have a head start here because most engineers are team players. It's the way we work. We work between disciplines, civil, electrical, control and instrumentation, mechanical, the whole gamut. So it should be easy. And when we work in new fields, we consult experts and we take advice and we adapt what we do. But sometimes we need to step back away from the coalface and have a look at the big picture. And our expertise in this is a little bit scarce, and that's a concern of mine personally. People who are able to step back, look outside their discipline and their speciality at the big picture, and come up with a balanced appraisal that enables us to move forward. That is a talent that needs development. As an example, the Infrastructure Transitions Research Consortium, sorry about that mouthful, but if you put ITRC into Google, you'll get it. They did this in the 2000s. They looked at how infrastructure would have to transition to meet the requirements of the UK in 2050. They pulled together, I think it was about 12 universities, academic institutions. They liaised with consultants and other institutions to come up with their reports and information. And they've recently come up with a report that shows that although transport, energy and buildings give us 79% of our greenhouse gas emissions in the UK, it's the water industry that will need about 50% of the finance because it delivers hazard protection. So that might be a surprise, but it's part of this big picture appreciation which becomes essential knowledge for developing government policy and future budgets. There is also an opportunity here for institutional sharing, and this is on the basis of individual engineers perhaps asking what their trade associations or institutions are doing, right up to the sort of thing that the IMechE is actively doing at present. Some of them are actively taking responsibility for their net zero targets. So, for example, Water UK, which is the body that represents all water and sewage companies in the UK, that has covered energy efficiency improvements in the past and now has a strategy for net zero operations by 2030. So they're well on the way. The Textile Services Association, which is washing machines, industrial users, that sort of thing, has made major reductions in their water and energy use based on the original concept of their standard washing machinery. So significant improvements there. So they're well on the way. And I'm sure there are lots of other trade institutions and associations who are doing similar. But if your particular association or group is a bit slow off the mark, ask if they need help. And if they do, or if you do, ask the IMechE. And I'm sure he won't mind me name-checking him here, but Matt Rooney is the chap to get hold of at the IMechE. he is linking all these things together and doing an excellent job. So some conclusions. Why are the political aspects of the Conference of Parties so difficult? Well, I have to admit that it probably has little to do with engineering. It may have more to do with the human condition, with our instincts to compete. And our leaders feel they have to keep up that particular show. But until we temper our aspirations with humility, we will struggle to live together in a finite world. And I think current events certainly illustrate that completely. But as engineers, we can show technically at least, and perhaps even socially, how it can be done. After all, we led the world into the Industrial Revolution about 200 years ago, so we can lead the world into the Green Revolution this time around as well. And I'm sure engineers are up for the challenge. Thank you very much for that, and I'll now take questions.
Oh, thank you very much, Roger. The floor is open to questions, and we've had a couple come in so far, so we can lead off with one of those if you're happy, Roger.
Indeed, Michael, please carry on.
Okay, so first is, what about upgrading the grid to have the capacity to transport all this electricity? It's a very good question. We're going to need to be moving a lot more electricity around.
Indeed, and for some very different places to what has been the historic norm. So onshore power stations are obviously fading down, where we're closing a lot of the fossil fuel powered ones, and most of the energy is supposed to be coming from offshore wind. So yes, there is a major restructuring of the grid required. I don't know what the investment program for that is. It will obviously cost a lot of money, but it's an essential part of rejigging the whole of the electricity supply industry to cope with offshore supplies rather than our traditional supplies.
Oh, thank you. One thing from your own industry, what about mitigating the methane industry, the emissions from the water industry? Those still remain at remarkably high levels, bearing in mind that the problem has been known about for a long time.
It has indeed, and the water industry, to its credit, has been generating electricity from methane, from sludge gas, to my knowledge, since 1936. The problem is that unless things have changed since I retired in 2013, it's not regarded by senior management as core business. Core business is treating sewage and getting it back into the rivers. Now, there was a major reshuffle on that, part of which I was an engineering and consultative part of. Part of it came through an energy efficiency programme initiated by UK Water Industry Research, which is the UK water industry body. And part of that, actually within one of the major water companies, came from a very charismatic manager who was ex-Royal Navy, who grabbed the problem by the scruff of the neck and said, look, this is absolutely stupid. You are wasting resources. Methane is a great fuel. Get it right. And he shook the place up. Now, unfortunately, one man cannot change an industry. But if you remember any of our Power from Poo presentations, that was central to that. But I mean, I remember some of the frustration.
Thank you very much.
I remember some of the frustration in dealing with methane leakages, and it was basically reconditioning things that weren't really core business, like digesters, were a means to an end. They were just a means of getting rid of sludge and discharging it again. And they weren't really looked after from the methane point of view. So yes, it's a valid question, and I'm not sure of the current industry emphasis.
Thank you very much. The other end of the equation, really, which harks back to our energy hierarchy, it says, thanks for the presentations. What are your thoughts on influencing and adapting behaviours as complementary to matching our energy needs?
Yeah, I do cover energy reduction later on in the presentation, but it was, and I think when you look at the numbers and the challenge that we face trying to upgrade our energy industry just to supply electricity, never mind all the fuels and gas, energy reductions have to be a prime target as well. And I think what will happen over this winter with the current highly publicised charge increases for gas and electricity, it's going to be very interesting how we as the public and as engineers aid and abet that transition to a low energy demand side, as well as providing alternatives. So I think the human race has traditionally exploited things until they've fallen apart, and then some civilizations have failed on that basis. And you've only got to read Jared Diamond's Collapse to realise that. So yeah, there's some very interesting history in this regard. But we thought we were cleverer than that, so I agree. We do need to get our heads around how we substantially reduce our energy demands. And some of these things are moral issues, not just political. Mr. Cameron started off the Warm Homes Initiative with a lot of money. Insulation of homes is obviously important. Yes, that would have reduced our current energy demand significantly. Then a few months later, he was persuaded to put the money elsewhere and cut the project by 90%. So virtually nothing was done. Now, that's not the priorities issue, that's a moral issue. We cannot have, in this civilized country that started the Industrial Revolution, the most energy-hungry houses in Europe. So I absolutely agree with the question.
Yeah, I mean, it speaks to the proposal yesterday for a £100 billion subsidy to continue burning natural gas, rather than a proposal for £100 billion to stop burning so much gas.
Absolutely, yeah.
An interesting approach. Next one, the question is, why do we not harness and utilise the heat in district heating systems as most other European countries have been doing for the past 40 years? We do not appear to be giving any consideration for this for new nuclear build in the UK.
Okay, nuclear is relatively easy to answer because there's lots of answers to this question. It partly goes to the previous one in that reducing our energy demand actually reduces GDP, and that is the god of growth to all politicians. Disposing of waste, for example, in a place like South East London CHP plant, that was supposed to link and supply the incineration heat into generating electricity to supply South East London. Easy, except that it never happened. They just burned the waste and left the generation side out. So yes, we should have been much more strict on the regulations and licensing for that sort of thing. On nuclear, nobody wants a nuclear power station in their backyard. So from district heating's domestic point of view, that is sort of understandable. My personal view is that we should have 5 small modular nuclear power stations inside the M25, so that whenever anybody in London switches on a light, they know exactly where it's coming from. But the other side of things is, you look at Avonside, which is only just down the Severn Estuary from the new nuclear power station being built there. That uses a lot of heat. There is still a lot of process industrial heat needed in places like Avonside. So yes, that should be linked up, but I'm afraid collaboration is dropping down the political and development agenda. So yeah, that is a great cause for concern. So agree with the question completely. It's again, it's a moral issue. Engineering and technically, it's probably fairly easy to resolve, or we could make our power stations an awful lot more efficient. but it's just too difficult in a political box.
That's it. Very interesting. One question here, it says it remains unbelievable that as an island with some of the highest tides and fast flows, that with water having significantly higher energy density than wind, that we're not building tidal storage, etc. Building flow energy infrastructure. And the question really is questioning, why do you think we're not actually doing that?
It's a difficult business model. If you look at the Severn barrage, you've got to do all that infrastructure, you've got to build that huge barrage, you've got to import protection rock, hard rock from Norway, which has an enormous carbon footprint, just moving and quarrying that stuff. Don't know why they didn't go for Welsh hard rock. Maybe there's not enough of it. But that all has to be put in place, and the final valve and turbine all has to be in place before you generate any income at all. Tidal turbines are a lot easier in that the first tidal turbine you install, you can start generating from. So that model is preferable, but in a place like the Severn Estuary, technically that is not the way for efficient energy recovery. And a barrage gives you, as the questioner has said, the storage and the other attributes that we need as a base load power source. So yes, I agree. The Severn, one or two of the other Welsh estuaries further north, Morecambe Bay, the Solway Firth. If you go all the way around the UK, there is adequate tidal resource to provide quite a bit of storage, which would see us over peak demand times. But the business model is very bad in the current climate.
Yeah, I've seen it. That's surprising. We only have time for a couple more questions. Questions come in. Apologies if they can't all be answered. But a very short one for you to start off with is, how long do you think we have before we run out of oil and gas?
Peak oil has been confidently forecast ever since I got involved in ESG in 2004. We thought then it was only a few years away because the US had taken off the official reserves some oil fields down the east coast of the USA. So they all of a sudden made them secret. And then they discovered oil shale gas in the parts of the Midwest and Canadian prairies as well. And all of a sudden we've got enough oil to deep fry ourselves many times over. So, but I'm reassured by listening to some investment specialists who say petroleum or crude oil based petroleum industry will be dead in 15 years. And that is because it'll be cheaper to run on renewable energy. It will obviously be less harmful, and the risks of being left with stranded assets will be far lower in the renewables industry. So investment specialists are looking to move their capital out of oil and gas and certainly out of coal. Now, that will obviously leave things like plastics development and things a bit up in the air. There will still be a demand for that. The challenge there is to make those materials and their generation into a completely circular economy so that we don't need new crude oil.
Yeah. Follow the money has always been a good way of seeing where future casting, really.
Indeed.
Well, that concludes the Q&A because we have unfortunately run out of time. There is a long list of them, so my apologies to everybody that have put questions in. But thank you very much indeed for those, and thank you very much, Roger, for a very interesting and thought-provoking presentation. I look forward to seeing everybody at the next webinar. There is a long program of them, and they're all very interesting indeed, and just as thought-provoking. And I hope we are able to engineer our way out of the hole we as a human race have dug sooner rather than later. So thank you very much.